Okay, so this is converting a recurring decimal into a fraction. Now most people know that that's just 54 over 99. If you had a calculator, you did 54 divided by 99, you'd see 0.545454. But let's have a look at the full technique, because just down below I've got two follow-up questions, and they'll be a little bit harder to do by just seeing them. Okay, so start with let x represent the answer 0.545454 and so on. And the key here is we're going to times x by a number, or we're going to times both sides by a number. The number you choose is 100. Now it's 100 because in the original question there are two repeating digits. So times the left hand side by 100. Now times the right hand side by 100. Now if you do that, you'll see you get 54.545454 Now by choosing 100x, you'll see what's happened pretty coolly is that the decimals have lined up exactly underneath each other. Okay, so at some stage the recurring parts of the decimal will line up with each other if you choose the right number to multiply x by. So now what we're going to do is we're going to rewrite x here. And then we're going to do a subtraction. Okay, so it's a bit of a technique, an algebra technique. We can subtract both sides of an equation. And we're going to leave the balance, the left hand side still balanced with the right hand side. So 100x minus x is 99x. And on this side, can you see that all of these guys just cancel each other out perfectly? So this is left with 54. And then finally divide both sides by 99. And we've got x is equal to 54 over 99. Now, yeah, I know most people could see that, and this seems a long way of doing things, but now think if you can try that technique with the two questions down here. 0.02 recurring, it's only one repeating digit, and 0.1234. Now notice it's only the 234 that's recurring, so that's 3 digits recurring. So pause the video and try those now. And then once you've unpaused, I'll show you the solutions. Okay, so we start again. Let x represent the recurring decimal. Okay, so one recurring digit, so times by 10. So we times both sides by 10. Everything jumps one place to the left. Then rewrite the old x equals. Try to line things up directly underneath each other, the decimal point directly. And then subtract. I've got 9x is equal to, well, 0.2, because I can see that all of these 2's cancel out. So divide by 9. But of course with fractions we don't like to have decimals within fractions, so the easiest way is to times the numerator by 10 and the denominator by 10, which takes us to 2/90. And you can leave the answer as that. Or you can simplify, because that would lead to 1/45. But both answers would be fine. Okay, but it's a technique. So the technique is key, that we kind of, with the subtraction, we get the recurring parts cancelling each other out. Alright, let's try the next one. I might just need another page for this to make it clear. Let's just copy. Let's just paste. Okay, so the same starting point. Do you remember what the starting point is? Let x equal or represent 0.1 and then 234, 234, ... and so on. Okay, now can you see there's 3 recurring digits? So we times by 1000, both sides by 1000. So we've got 1000x. Okay, now I've got to be careful with the working out here. Let me just see. 1, 2, 3. Okay, so it'll be there. 123.42342344 ... Okay, So now then write down the x again. X equals, and make sure you line up the units with the units. 0.1234234. Okay, so that's the most important part, trying to line things up very carefully. Right, now do the subtraction. 1000x minus 1x is 999x. And can you see that this is 123.3, and of course everything else cancels out. Divide by 999. And again, before we said we don't like decimals within fractions. For a fraction to be a proper fraction, we need to have integer divided by integer. So that's times by 10, times by 10. That's 1233 divided by 9990. And again, let's not worry about having to simplify to its simplest terms there. The important thing here is changing from the decimal to a fraction, and you've done that.